8.5, trigonometric or polar form of complex numbers. Rectangular form is what we're used to, and we like rectangular form. It's going to have an x and a y. It's going to look like x plus y I. And so, for example, you're going to have like 2 minus 3i or something like that. And you're going to need to be able to identify the x number is 2 and the y number is negative 3. It looks an awful lot like an xy point. Polar form looks a little bit more complicated. It's going to look like this: r cis theta, or the longer form, r times the quantity cosine theta plus I sine theta. Now that looks really, really complicated and confusing. I like the short form better, cis, and understand that cis is just an acronym. It stands for cosine I sine. So that cis is just an abbreviation of cosine I sine. But all we really want is the r and the theta. So an example, you're going to see something like 4 cis 50 degrees. I just need that radius number and that theta number. That's what I'm looking at to be able to draw the vector. So they show you how to draw a vector. And here's an example right here, 2 minus 3i. Notice they go right 2 and down 3. That puts us in the fourth quadrant, but we can draw that vector. The next example, they show you how to add. Here's a vector, 4 plus I. And 1 plus 3i. So go over 1 and up 3, or over 4 and up 1. Notice that I, when it says I, that's 1i. So your y number is 1. But then they show you how to add, but it's really simple because you're just adding the like terms. 4 plus 1 is 5. 1i plus 3i is 4i. The sum right here, 5 plus 4i. 5 plus 4i. So they're just showing you how to add two vectors, like so. And then that's exactly what they want us to do for example 1. Graph both complex numbers and their sum. I'm going to find the sum first. The sum, add the like terms. 6 plus negative 4 is 2. Negative 2i plus negative 3i is negative 5i. So that's going to be the sum. But I'm going to graph the two vectors and their sum. Here's the first vector, 6 minus 2i. So I go right 6, down 2. 1, 2, 3. Let's zoom in a little bit. Okay, right 6 and down 2 is going to put us right there. I want a vector magnitude and direction right there. That's 6 minus 2i. Then I would do, here, let's go ahead and label it 6 minus 2i. Then I want to do a second vector, negative 4 minus 3i. So left 4 and down 3 puts me right there. Magnitude and direction. Don't go too far. Don't go through the point. This does not go on forever. Let's label it negative 4 minus 3i. And then we want the sum, 2 minus 5i. So right 2 and down 5 puts me there. 2 minus 5i. We can graph vectors. We can find the sum. We can graph the sum. Now we want to do polar form. And polar form, we don't really know how to do the sum yet. So we'll do the sum later once we know how to convert. But for right now, let's just graph them. 8 cis 50. Okay, all I really care about is the r value and the theta value. So there's a radius and there's a theta. And we can see the theta real quick is 50 degrees is right there. Okay. But that 8, that radius of 8, if you think about it, you can count out. I start at the origin and go out 1, 2, 3, 4, 5, 6, 7, 8. When I get to 8 right there, that corresponds with a circle of radius 8. So you kind of want to follow that circle around to where it would intersect with that 50-degree angle right there. That point right there would represent the intersection of the circle of radius 8 with the angle of 50 degrees. That's where my vector would be. Don't go past the radius of 8. But that's your 8 cis 50. Or 8 times the quantity cosine 50 degrees plus I times sine 50 degrees. We look at the other one. It says 6 cis 120. So a radius of 6 would be this circle right there. And 120 is over here. You follow that circle around, radius of 6, to where it would intersect with 120. Is that 6? 1, 2, 3, 4, 5, 6. Yep, that's 6. So we want a vector which has direction and magnitude. Don't forget the arrowhead. If you forget the arrowhead, then you don't have direction. Okay? Direction and magnitude. There's 6 cis 120. Now again, we're not going to do the sum just yet because we'd have to convert. And we haven't learned that yet. But that's where these formulas come in handy. You're going to want to learn these formulas. These are your conversions. Highlight them, put a star by it, but you need these 4 formulas. Rectangular form, please remember, is going to be x plus y I. You're going to need an x and you're going to need a y. So you will use those 2 formulas. I think this is the easier thing to do, is to find the rectangular form, to find the x and y. For polar form, you're going to need an r and a theta value, and you're going to use these 2 formulas. One thing that's tough is you must find the quadrant. Your calculator, you're going to use a calculator here, but your calculator is not going to tell you the whole story. It's going to tell you most of the story, but you're going to have to fill in the last part, which would be what quadrant we're in, and figure that out. Okay? Now, square root approximations. Your calculator is going to give you a decimal number, but MathXL is going to force you to enter in an exact answer, which is usually going to be some form of a square root. So some very common ones that you'll see. Square root of 2 looks like 1.414. Square root of 2 over 2 looks like 0.707. If you see those numbers on your calculator, convert it back to the square root. Square root of 3 is approximately 1.732, and square root of 3 over 2 is approximately 0.866. Okay? If you see those numbers on a calculator, go back here, use the exact square root. Example 2, we want to convert 2 cis 300 degrees to rectangular form. So this is the one that we like doing. Rectangular form is x plus y I. In other words, I need an x number and a y number. I'm going to use those red formulas up there. I notice that I've got r and theta, but I want x and y. Specifically, the formulas say x equals r cosine theta and y equals r sine theta. So it's pretty much just fill it in. R from the problem is 2, and theta is 300 degrees. So I'm going to do 2 cosine theta and 2 sine, well, theta is 300, so 300. Now, sometimes you can just type it in and your calculator will give you the answer, but other times that will lead you to confusing results. So here's what I want you to do. Split it up. and just do the cosine 300 part. So you've got a calculator, and your calculator hopefully is in degrees. You would type in cosine 300. Cosine 300 gives you 0.5. If you don't have 0.5, that means you're in the wrong mode. Get a calculator now so you can practice. Cosine 300 is 0.5. I'm going to say that's 1/2. It'd probably be better for you to use fractions. So 0.5, 1/2 right there. Okay. Sine 300 is that messy looking decimal. You're going to get messy looking decimals. But that one looks familiar. 0.866. Is that on your list? What's 0.866? Okay, good. Square root of 3 over 2, right? So it was negative, so we're going to have negative square root of 3 over 2. Twos cancel, I'm left with 1. Twos cancel, I'm left with negative square root of 3. Now, something to notice is, remember, we wanted x plus yi, so it looks like 1 minus square root of 3i right there. That would be your answer. Your x number is 1. Your y number is negative square root of 3. Now, I will say this. Most of the time, people don't like the I written at the end. So your I is almost always going to be written before your square root number. And so you might have to enter your answer like this. Both of those are right as far as I'm concerned. But the one at the bottom is probably more frequently used. People might get confused about whether you mean for the I to be under the square root if you write it in red. All right, part B. Convert to polar form. This one's going to be a little bit harder. Polar form, remember, is R cis theta. We start with an x number and a y number. But be careful because y is just everything other than the I there. So for the y number, you got a negative and a 4 and a square root of 3. That's your y. Okay? So we need R and theta. Look at the formulas for R and theta. A little bit more complicated this time. R is the square root of x squared plus y squared. Be careful with this. So the x number was 4. That's easy enough. We'll have 4 squared plus. The y number, though, was negative 4 square root of 3. So we've got the square root of x squared plus y squared. So we do those squares. 4 squared is 16. And then when you square the other part, use a calculator if you want to, but negative 4 squared is 16, and square root of 3 squared, you need to know this, is 3. Anytime you square a square root, it's just going to cancel out. Square root of 3 squared is 3. So inside there, that's 16 plus 48, or square root of 64. R equals 8. R equals 8. That's not always going to be a nice number like that. You might have to reduce a square root. Now, I need theta, and I've got a different formula for that. Tangent theta equals y over x. And y was negative 4 square root of 3, and x was 4. Looks like that. Tangent theta equals negative 4 square root of 3 over 4. You can cancel the 4's if you'd like. And so it might be a little easier on the eyes if you look at tangent theta equals negative square root of 3. Now, we are solving an equation. This is an equation, and we want to solve it. So how we solve equations in math, from day one, Algebra 1, you do the inverse operation. So think back 4 years ago, x plus 2 equals 8. you subtract it. You did the inverse operation. Okay, I wouldn't call it the opposite. You're not doing the opposite, you're doing the inverse. If I said 2x equals 12, you divided because this was multiply. So whatever the problem says, you do the inverse operation. That's what we do here. We're going to do the inverse operation of tangent. We're going to do an inverse tangent of negative square root of 3. Inverse tangent of negative square root of 3. So you're going to have to hit the second button or the shift button. Inverse tangent of negative square root of 3. Your calculator will tell you negative 60. That's not the answer. That's not the whole story. Remember up here, it says must find the quadrant. Okay? And this is going to be important. Negative 60 is part of the story. But we've got to think about what quadrant we're in for this vector. This vector says x is a positive number 4 and y is a negative number, negative 4 square root of 3. So if you think about a plus minus, as for what quadrant we're in, plus minus would definitely put me in the fourth quadrant. Okay? So what you have to do for this one, and this is probably the hardest part because it's new, but you have to put a 60-degree angle in the fourth quadrant. Okay? So listen very carefully. You always go off the x-axis. So if you start at the x-axis and go 60 degrees right here, okay? That is a 60-degree angle in the fourth quadrant. That's what my calculator told me to do, okay? As for your answer, though, you have to tell me what this angle is, okay? So go back up here and look at the graph paper, okay? Here's 0. Or 360, and we had a 60-degree angle that took me back into the fourth quadrant, okay? So I care about this angle that takes me right here, but think about it. 60 away from 360 is 300. It should make sense to you that that's going to be a 300-degree angle, and I didn't really have to graph it. I can kind of sketch it if I want to, but 60 degrees away from 360 is 300. Theta equals 300 degrees. I know that's the hardest part. We're going to practice that though. So your answer, 8 cis 300 degrees. That is the vector in polar form.